And looks like we're up and running. Hey,
Oh,
you do that well.
oh,
Welcome everybody, and welcome back to the Sunday Night Astronomy Show. Just need to make sure that we're live here on YouTube. I guess we are. Looks like we are. Okay, good evening everybody, and welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show. First of all, I'd like to welcome back our co-host, Royal Astronomical Society of Canada member, Mr. Paul Owen from Moonshadow Observatory in Hampton. Hey, Paul.
no.
And unfortunately, our other co-host, Mike Powell, is working this evening, but he's with us here in spirit for sure. We'll miss you, Mike, but he assures us he'll be back with us again next week
Oh, yes.
for sure. Well, tonight we've got another full show planned for you. We're going to start off with our regular What's New in Space segment. If you spend some time capturing a deep sky treasure and want to learn to display that photo so that it brings out the best of your capture, then Paul's going to give us some hints on that tonight, right, Paul?
We're going to try.
Yeah. Also tonight we're also we know that it's difficult to step outside on these cold winter evenings. Sometimes you just want to go out and take a quick look at the night sky. Well, binoculars provide you with that option. So tonight we'll discuss why they work so well for stargazing and what you should be looking for when you're buying a set. And we'll take a look at some of our favorite winter sky targets and how to find them. And then after that, Paul's going to return with another interesting segment of Rosanna's Fun Facts. Plus, we'll have your wonderful photo submissions, and as always, we'll take all of your astronomy-related questions. So sit back, I guess, and enjoy. And remember, this is a family-friendly live broadcast. So let's get started, I guess, with a brief view of what's new in space this week. It'll be up to me.
No, you.
We're still, looks like we're all live. Hey, Mike. Good evening, buddy.
Hey.
Hey. Chicken coop salute to Mike. Chicken coop salute to Mike. We'll take that. All right, let's take a look at what's new in space this week. So I'll present now. Entire screen. And we'll go with this one. Share. And we're going to go to full screen. All right, let's see where we can go here. Find my mice across my 5 screens here. And I think I'm going to start with this one. Make sure we get a good display there. All up and running?
Yes.
All good? Okay, let me get this window moved to someplace else. 1 second. Here, I'll put that up on my number 4 screen. Okay. And waiting for it to show up on Facebook here. Should be any second now, I think. Okay, so Curiosity, the rover that's been exploring the planet Mars since it touched down on the red planet on August the 6th, 2012, just celebrated its 3,000th day on Mars on January 12th, 2021. It's important to note that those are Martian days we're talking about, which are known as sols, and they last 24 hours and 40 minutes, actually. The Mars Exploration Rover has spent that time admirably cruising around and investigating the Martian climate and geology, in part to determine if Mars is habitable or if it ever was in the past. In December 2012, Curiosity's mission was extended indefinitely, so we're likely to get a few more sols out of this bad boy before it finally retires. In its time on Mars, Curiosity has traveled 14.87 miles and has provided detailed images that you can explore on NASA's website. It also features a ton of technologies on board that have potential outside of space travel. Now, the Chemical and Mineralogy Instrument, or CHEMIN, for example, is designed to perform a chemical analysis of powdered rock to determine the types and amounts of materials that are present. But it also serves a purpose at the Getty Conservation Institute. It can date and evaluate works of art without causing them physical damage. Well, soon Curiosity will be joined by the Perseverance rover, which launched from Cape Canaveral, Florida, on July the 30th, 2020, and it is scheduled to touch down on Mars in about 5 weeks. On February 18th. Again, the purpose of that mission is to evaluate the composition of Mars in order to determine if it can be habitable. About 85% of the new rover is based on heritage hardware. The big change here is that Perseverance will have more higher quality cameras to provide more detailed images. It is also designed to take rock samples back to Earth. And let's go on from that one to the next topic. Just gotta get my mouse in the right spot. Here we go.
Yes.
Okay, meanwhile, the rest of, oops, sorry. Meanwhile, let's go back to my notes. No, I'm missing the page.
Oh, no.
Oh, no, I hate it when that happens. Oh, no, I get the right page. No, 1 second. Oh, no. They printed off the printer the wrong order. I'll be right with you, folks. Don't you love this live stuff?
Oh, yeah.
Bear with me. Oh, here we go. To make the, there, okay, I think I'm right. Meanwhile, continuing with Mars, NASA has pulled the plug on its InSight lander's Mars mole more than 2 years after the lander touched down at Elysium Planitia. The German-built Mars mole heat probe could simply never penetrate the hard exterior surface of its landing site in order to make the kind of measurements necessary to give planetary scientists the first real clues as to the makeup of the Martian interior. For nearly 2 years, the InSight, short for Interior Exploration Using Seismic Investigations, Geodesy, and Heat Transport, mole probe has been attempting to burrow into the Martian surface to take the planet's internal temperature. But the soil's unexpected tendency to clump deprived the spike-like mole of the friction it needed to hammer itself into a sufficient depth. This would have enabled planetary scientists to better understand whether Mars' interior is radically different from Earth or from our own moon. The mole itself is a 16-inch long spike designed to drag with it a ribbon-like tether that extends from the spacecraft. The idea was that temperature sensors are embedded along the tether to measure the planet's interior heat. But InSight landed in an area with an unusually thick Dury crust or layer of cemented soil. Rather than being loose and sand-like as expected, the dirt granules stuck together. Meanwhile, the rest of InSight's instruments are functioning and taking data. In fact, InSight's seismometer has recorded more than 480 Marsquakes. Along with hunting for Marsquakes, the lander hosts a radio experiment that is collecting data to reveal whether the planet's core is either liquid or solid. And InSight's weather sensors are capable of providing some of the most detailed meteorological data ever collected on Mars. Together with weather instruments aboard NASA's Curiosity rover and the Perseverance rover, which lands on February 18th, the team says that the 3 spacecraft will create the first meteorological network on another planet. And it has just recently been announced that InSight will be listening to see if it can measure the impact of the Mars rover when it arrives next month. Now, I need another moment to get my notes together. If something fell.
Yes.
Hello?
Hello. What else did you drop?
Here we go. Okay. The year 2021 has only just started, and scientists already discovered a new comet that might become the brightest of the year, Comet C21A1 Leonard. On January the 3rd, an American astronomer, Gregory Leonard, discovered a new comet at the Mount Lemmon Observatory in Arizona, USA. It was named C2021A1 Leonard, the letter C meaning non-periodic comet, and 2021A1 indicates that it was the first comet discovered in the first half of January 2021. A specific feature of the comet Leonard is its incredible speed, about 70 kilometers per second. It's moving 6 kilometers per second faster than last year's comet Neowise. Due to such speed, the comet's position in the sky will be changing every day when we observe it from the Earth. Comet Leonard has a hyperbolic trajectory, which means that it will cross the solar system only once and then move far away from us and will never come back. So you only have one chance to see it. Unfortunately, to observe Comet C2021A1 Leonard, you'll have to wait till almost a year. The comet will get closer to Earth and will be best visible on December the 12th, 2021, passing by our planet at a distance of 34 million kilometers or 21 million miles. After reaching the closest point to Earth, Comet Leonard will also pass quite close to Venus, about 4.2 million kilometers or 2.6 million miles. By the way, in the history of astronomy, only 5 comets have been closer to the Earth than Comet Leonard will be to Venus. The comet is currently too dim to be observed even through telescopes. However, in December 2021, it might reach naked eye visibility, shining with a magnitude of 5 or 4. Now, on top of that, as Comet Leonard will be positioned between the Sun and Earth, its magnitude can even reach 1.5. So, yeah, if you live in the northern mid-latitudes, you can start observing Comet Leonard as early as September. It will be slowly passing near the constellation of Ursa Major, Canis Venatici, and Coma Berenices. In the first half of December, the comet can be seen in the constellation of Bootes, Serpens, Hercules, and Ophiuchus. After that, it will move to the southern celestial hemisphere. It's too early to say if Comet Leonard provides a spectacular astronomical show by the end of 21, but let's hope for it. After all, that's what we love about comets, their ability to keep us on the edge of our seats, always waiting for a pleasant surprise. And finally, more than 3 decades worth of government UFO records are now yours to download and pursue, thanks to the efforts of some intrepid truth seekers. The massive data dump includes more than 2,700 pages of UFO-related documents declassified by the CIA since the 1980s. The U.S. government also calls them unidentified aerial phenomena, or UAPs. The documents were obtained through a long string of Freedom of Information Acts requests filled over the last quarter century. Now, over time, so many requests piled up that the CIA created a CD-ROM full of declassified documents known as the UFO collection. In the mid-2020, Greenwald purchased the CD-ROM as he recently finished uploading his contents as a series of searchable files on his website. You can find them at theblackvault.com. The documents cover dozens of incidents, including the 1976 account of the government's then Assistant Deputy Director for Science and Technology being delivered a mysterious piece of intelligence on a UFO, to the description of a mysterious midnight explosion in a small Russian town. The data dump arrives months before officials from the U.S. Department of Defense and intelligence agencies are due to appear before Congress and spill their guts on everything they know about UFOs. A provision attached to the COVID-29 relief bill passed in late December requires the agencies to submit a report within 180 days to the Congressional Intelligence Committee on unidentified aerial phenomena. The provision provides a banner year for UFOs when startling footage of an unidentified object darting around several U.S. Navy planes in 2004 and 2015 was finally declassified. Well, while the new data dump is significant, it's also just a drop in the bucket of the Black Vault's enormous archive. The website reportedly contains more than 2.2 million pages of UFO-related material in its archive, which Greenwald obtained through more than 10,000 requests. According to the Vault website, Greenwald filed his first request back in 1996 when he was only 15 years old. And you can check out the declassified info for yourself at theblackvault.com.
Wow.
And that's what's happened in space this week. And I wanted to mention, coming probably next week or within the next couple of weeks, I'm going to omit the What's New in Space segment, and I'm going to replace it with this segment called Where Are They Now? So these are all of the spacecraft that have ventured throughout the solar system and beyond. And each week, or every couple of weeks, I'm going to take one of the spacecraft and we're going to talk about it. Probably one of the first ones I'd like to talk about will be the Voyager spacecraft, the one I'm probably the most fascinated with. So that'll be coming up in future weeks. So that's all I get to say about that one.
Yeah, oh, that's very cool.
Cool stuff, eh?
It is cool stuff.
UFOs are there.
It's far out.
Far. Okay.
I remember when I was little a couple of years ago.
You were little? Okay. That was yesterday. You're still little.
And I always, before I got a little mature astronomy-wise, a lot of this stuff always, kind of tickled at the back of your mind. I wonder, is this true?
Yep.
Anyway, it's just interesting to see it now, especially a lot of the stuff you see in magazines, the Inquirer and pieces like that, where you see the crazy stuff. that some people still are kind of taken for real. So
Oh yeah, Weekly World News is the best one. I'm a subscriber for that now, so I'll keep you posted on what's going on there. Anyway, okay, let's say hello to everybody out there tonight. Kathy says, "Hi, hubby and I enjoyed the sunset tonight. Awesome, Kathy. Nice crescent moon out there this evening too. And we're going to talk a little bit about that a little bit later. Hello, Lisa, Robert, and everybody else out here. So let's move on to our next topic because we're getting into 8:16 already. My goodness, the time just flies. You're having fun or not? Okay. So Paul's going to carry it away now on a talk on processing your images, how to take all that data and process it properly to get you the best image possible.
Yeah.
Over to you, Paul.
What I'm going to talk about is sort of that little thing that you do in between when you acquire all your data, if through your telescope and all that kind of stuff, and then your camera, and just before you start to make it a pretty picture, there's some things that you have to do to first of all, there's things you got to do while you're acquiring it, and it's not just taking pictures. There's also taking other special kind of pictures that you have to kind of blend all in together. And that blending process is what I'm going to talk about tonight. And that's what they call calibration frames. Now I'm going to show, or I'm going to try to show a picture first, and then I'll get into a little bit of a talk, and then we're going to show you actually some of the things that go on with it. But the basic thing about calibration is what is calibration and why do you do it? And a lot of people, have seen these beautiful pictures on the internet, and they say, "Oh my gosh, that's gorgeous. Must be nice just to get out there and take your camera and take a picture like that." But it doesn't happen like that. In order to get some of the photos that you see, there's basically hours and hours and hours of acquiring data, information, and then you got to put it all together, and then you spend more hours processing the thing, and then by the time it's all said and done, you might have 15, 20 hours into one picture. Whereas people who aren't familiar with acquiring an astro image, they don't realize the difference between taking a snapshot and actually, acquiring data to put together to come up with an image. And the reason a lot of people do it, number one, some people do it because they like pretty pictures. Some people do it because it's a great way to study all the objects that are in space, because when you just observe them through a telescope, most of the things that are deep sky related are basically smears and smudges in gray for the most part. So what you see in a calendar or on the internet, there goes my my light. I told you that was going to happen. Where did I plug it in? There it is. I might get some of the light back, but we'll see. I'm going to slip to my screen anyway, so that'll that's about as bright as I can get with that light. So in any event, yeah, so to get those photographs, there's a lot of process that you have to go through. But some of the processes I was asked to talk about was what they call calibration, where you have to take not only the pictures of the target, but there's supporting pictures that you have to take to reduce some of the noise. So the whole point behind doing calibration is to take and give you what they call better signal to noise. In other words, you want more of the picture and less of that noise. So that's what we're going to talk about tonight. So I'm going to show you at first. I'm going to take and turn on, I'm going to try to present and show you a picture first. And let's see if we can get that picture to come up. Okay, so there it is there. So here's the photograph that I took the other night, and it's basically of the Horsehead Nebula. This is in the constellation Orion, and this is one of the goodies that is probably one of the most photographed things in the night sky. But in order to be able to have that picture turned out like that, nice and clear, and with a lot of nice color, nice even background and all that stuff, there's some very important things you have to do before you even start to actually put the color to it. And that's what we're going to show you. And we're going to talk about calibration frames. So I'm going to see if, in fact, I can get this thing to work here. And let's see what happens. Oh, there it goes. Now, all I got to do. Okay, there we go. So calibration frames, what are they, and why do I need them? So basically, what calibration frames are is it's basically a culmination of different types of frames, and I'll go through these one by one. The first thing that you want to do is collect your data on your target, so your light frames. So what are light frames? Well, those are the pictures. These are the actual images of the target that you've taken. The more of these pictures that you take, the better the resolution of your image will be. And the more you take, the higher the signal, the picture itself, to noise, which is the graininess that you will have. So that's why when people take pictures of astro images, and you've heard me talk about it before about stacking a bunch of pictures, that's why we take a bunch and stack a bunch, is because we want that better signal to noise ratio. Secondly, is the dark frames. Now, what are dark frames? Well, dark frames are taken to remove the hot pixels and amp low, if your camera has that, and general sensor noise. You should take between 20 and 50 of these particular frames. So you can take these when the weather isn't good, or through the day when your camera, or if your camera is cooled. Now, what I mean by that is, for a DSLR, for example, these particular frames should be taken just before or just after your light frames. And the reason for that is you want to keep that temperature on the sensor as close to the light frames as possible, and thus creating more equal sensor noise between the darks and the lights for good subtraction. Now, if you're using a cooled camera, which I am, and a lot of people are, which is not a DSLR, but it's a special Astro cam, and those have coolers built into them, so you can keep your temperature consistent. So whether it's in the middle of the day, the middle of the night, the atmosphere around doesn't make any difference. It's how cool you can keep that sensor, and by having a cool camera, you can control that completely. So that's basically the difference between a cool camera and a DSLR, and the importance of having those dark frames being taken with a DSLR at the same time that you're taking your lights. Now, these must be the same in length. So in other words, if I took a 3-minute picture of that Horsehead Nebula, then I have to take a 3-minute dark frame. They must be the same temperature, and we just talked about that. And the exposure length, excuse me, and the exposure length has to be the same as the light frames. So those are the 3 prerequisites when you're doing your darks: the same length, the same temperature, and the same exposure. That's very important. Then there's flat frames, and people might have heard this term before. And so what flat frames are required to take care of the vignetting. So in other words, if you look at a picture, and it's kind of like somebody taking a circle and putting it on a square, and then you got the corners around the edges, they tend to get dark. That's called vignetting. And then there's dust in your optical train. So lots of times you'll see little spots all over your picture. And if you take daytime pictures, you'll see them. Sometimes you take a picture of the sky. Maybe you're taking a picture of a landscape, and you get a little dot on there. Well, that's dust. Those things show up in astro images. And so the flat frames are responsible for taking that stuff out. So these frames should be taken right after you do your light frames, in order to keep the optical aberrations the same for subtraction. And so that simply means that if there's dust on your filter that you're using, if there's dust on your camera lens, if you take that picture, say 2 or 3 days later, and you maybe adjust the focus or maybe turn the angle of your camera, well, then your flat frames aren't going to line up and be subtracted off of the light frames anymore, because you've altered everything. So it's very, very important that you do those as close to as possible of the time that you took your light frames. So flat frames are taken with evenly distributed light. I'm going to show you an example of this in order to mitigate the dust and the vignetting for a more evenly illuminated image. And the most common method is stretching a white t-shirt over a telescope and use a light panel or a laptop to illuminate the sensor. If you're using a DSLR, most people who are using DSLRs, when they're doing this kind of photography, they know that there's a little histogram on the back of the DSLR live screen, and you want to keep that when you're taking these flat frames, you want to keep that 1/2 to 2/3 on the back of the camera on your screen, so that you're getting the proper exposures, so that you can get these things done correctly. And then finally, these ones are not as important depending on the camera and depending on how you're taking them. But I want to make mention of them. I do use them. In my particular camera, I take what we call flat darts and or bias frames. So basically, bias frames are taken to capture the read noise of the sensor. When averaged out, it becomes an inherent gradient to the sensor. So bias frames are meant to capture this for removal. These frames are taken with very short exposures with the scope cover on and in a dark environment. In fact, if you're just doing bias frames, it doesn't even have to be on the telescope. You can take it off the scope because the temperature doesn't matter, because this is all done with no light actually getting on the sensor. We're just taking what the sensor creates on its own without any light on it. And flat darks, which is what I do, are taken as flats. So it's the same process that I do to take a flat frame. The only difference is I put the cover on it. So it's just like when I was doing my regular pictures and I was doing my dark frames. A flat dark is just a dark frame for a flat image. That's all it is. So it's done the same as for your light frames. Now I'm going to show you some of this stuff, put some visual to it for you. So taking dark frames, when you take a dark frame, so here's my rig. So if I'm going to take a dark frame, now this is in the daytime that I took this picture. So normally this would be at night and this window wouldn't be letting light getting through, and I've got my lights on inside. But when you're taking dark frames, you want the room as dark as you can, and you're going to cap your scope. If you're using a DSLR back here to take your images, it's always in good order to cover the DSLR when you're doing dark frames, because that little mirror that you look through, or that little finder that you look through, it allows light to get down inside the body. So you want to cover that. Or if you're familiar with cameras at all, on most cameras, on the strap that goes around your neck, there's a little piece of plastic that's actually designed to slip right in when your viewfinder goes, and that blocks that off. So anytime you're doing astro images, it doesn't allow any light to get through there. So that's basically what you're doing for a dark frame. So again, once I've done taking all my light frames, and if I'm going to do my dark frames at the same time, and the reason I suggest doing that in the beginning until you build up a library, because once you've developed enough dark frames, when you're using a cooled camera, you can do these anytime, and you can build up a library and you can store them so that when you need to use them again, you just go back into that file and just dump them in. If you're using a DSLR, depending on if you're going from winter to summer, there's probably going to be quite a change in the noise on your camera. So you could try using them again, see what happens. But if you don't, then again you'll take those at the same time. So once you're done your light frames, you might say, okay, it took me say 2 hours to get my light frames. Well, now it's going to take me 2 hours to get my dark frames. You're going to go through exactly the same process, except your scope's going to be parked, and you're just going to take pictures with the cover on the front of your telescope. To do a flat frame, it's basically what has to happen is you have to, like we talked about earlier, you have to have illuminated light source. So this is inside my observatory. And what you have to do first is you have to take a white t-shirt, which is a method that I use, and I stretch it over the front of my telescope. And then I make sure that's nice and tight so there's no wrinkles in it, because I don't want any wrinkles to be processed on the flat frame. Then what I do is I turn on, I have a light pad, and I turn that on, and then basically I point the scope right directly at the light pad. Some people just take, if they haven't got this kind of a rig, they'll take an iPad, they'll point their scope straight up, and they'll just take their iPad and lay it on top of the scope, and then they can adjust it from there. But basically, this is the method that most people use for taking flat frames. If you choose to do this outside, if you don't have an observatory and you don't have a light like this, as it's getting dark or as it's getting light in the morning, the sky itself is pretty evenly lit. So you can basically do the same technique, put the t-shirt over it, point it at the sky, and you should be able to get your flat frames that way. So that's what I want to show in terms of this particular slide. Now I'm just going to try to get out of this. There we go, and that should come back here in a second. Back to that picture, and back to me. Okay, here I am. Now, I want to show you now what those calibration frames do. So I'm going to open up, I'm going to try to open up my PixInsight. There we are. And I want to show you what happens when you don't take these calibration frames. And I want to show you, first of all, what you're actually subtracting from your pictures. I'm going to show you my dark frame first. So you can see there, you're looking at that, you're saying, what the heck is that? Is that a big bright star? Good golly, look at that big bright star in that picture. No, there's two of them. Look, there's one over here. There's one over here. Well, that's not stars. What that is, that's what we call amp glow. That's what happens with the CMOS camera that I'm using. And a lot of cameras out there have this amp glow. So when you take those dark frames, it's going to eliminate the amp glow. And all those white specks that you see there, those aren't stars. Those are hot pixels. So this is what goes on. This is the kind of noise that your sensor actually creates. And then your sensor reads this as noise, and it gets mixed in with your picture. So this is why you take a dark frame, because you want to eliminate this kind of stuff. So that's my dark frame. My flat frame. Now, I'm not sure what you can see on your screen. I'm going to try to make this a little bit more visible for you. So let's see if I can do that. Whoops. Put a preview on first. There we go. Okay, so you can see here now on this particular frame, you see those circles, those black circles? So that's dust. That's dust in my optical train. So that could be on my filter, that could be on my camera sensor, that could be on my flattener or my telescope, that could be just about anywhere. So the whole idea behind taking flat frames is we want to get rid of those donuts, because when you're going in the process mode, these things will show up, and then all of a sudden you've got these things in your picture, and now you got to deal with trying to figure out how you're going to get rid of them. And you don't want to have to do that to yourself. And on top of that, if you look at the corners, you see how the corners are darkened out? So the corners are dark because that's what they call vignetting. So that basically is light drop off from the telescope's opening going on to the sensor. And if I had a larger sensor, I may not get that light drop off, or maybe it's just because the light path that I have is smaller than my sensor. So the reason I'm getting the vignetting, I guess, is irrelevant. The point is we want to get rid of it, because we don't want those dark corners in our image, because then we don't have a nice flat evenly illuminated surface, thus the name flat frame. So that's the reason we take the flat frame. So I'm going to shrink that one up. And now I'm going to show you the difference between taking an image. And the reason this is green is because my camera, this isn't debayered yet, so I've got a green cast. So ignore the cast, because what I want to show you is the stuff that's on the image. So remember when I said with the Master Dark, you see all that light, that amp glow coming from my camera? Well, there it is. It turned up in my picture, didn't it? So the only way I'm going to get rid of that is I'm going to sit there and play with it for hours in Photoshop, trying to get rid of those lines. And if I do that, I'm probably going to get rid of some of the stars. And then I've just taken the validity away from my image. So the only way to get rid of that is I'd have to crop it. I'd have to take and find out where that light stops. And then I would lose all that information because I didn't take my dark frame. And then my flat frames, you can see here in the corners, I've got all of this uneven illumination going on. And if I really stretch that image, you'd see all those dots. So this is an uncalibrated stack of images. Now let's get a little closer. And I want you to look. And this is only 10 images. We talked earlier about getting as many images as you can, because the more images that you get, the better picture to grain that you're going to get. So this one on this side is only 10 subframes. This one on this side is 49. Let's look at that same image. Whoops. And let's look at the difference in the noise. So on this one, I don't know if you can see it on your computer at home, but boys, look at the dark areas, especially. There is noise all over the place. And I didn't do anything to either of these frames other than just take them and put them up here. The one on this side, I used more images, so I got a stronger signal to noise. But more importantly, I used the calibration frame. So you're going to see that now all of this amp glow and my bad dark corners and all of that stuff is gone. So I have a nice evenly illuminated surface to start with. That amp glow is gone. All of those little tiny white hot pixels are gone. Any kind of other noises that the camera would have left on these images is taken out. And the reason that happened is because I took the time to do my calibration frames so that I could get rid of the noise, the glow, the hot pixels, the banding, and all the other stuff that happens if you don't do that. So now my processing on this picture is going to be so smooth and so easy because I took the time and took care of all this. So you could have this, or you could have this to start with. And there's really no question which way I would like to start. And that's how we ended up getting this image looking, you know, like that, which turned out actually quite well because I did all of the things that I need to do in the beginning, and I didn't lose all of this section of my image because I didn't take the time to take my dark frames and get rid of that amp glow. And that is my story.
That's a great story. That's a great story.
Yeah.
Awesome. Well, let's see what we got for questions, Paul. I think I might have had a couple here. Just a sec. Robert says, very good explanation. Awesome. ZWO camera, Paul, Stefan asks. Is that the camera you're using?
Yes. Yes, okay. I have ZWO ASI 294 MC Pro, and it's a one-shot color camera. And it's probably the most popular color camera in the ZWO lineup. Price-wise, it's $1,400, so it's really reasonable. And what's cool about that camera is not only can I do my deep sky stuff with it, but I also use it to do my planetary stuff. So you can do both planetary and deep sky with that camera.
Okay. Renat's asking, blending, is there an app for that?
Sure. Yes.
Okay.
There's if you're going to blend your pictures that are like what we're talking about here with deep sky, and you want to stack them all together so that they're all lined up and all that kind of stuff, registered and so on. There's an app or a program called Deep Sky Stacker, and that's what I started with. I do it now in PixInsight, but it's a Deep Sky Stacker is what it's called. It's so simple to use, and if you ever want to see it sometime, maybe on another show, I can show a demonstration of how easy it is that you to do stacking with that software.
That'd be excellent. Great. So she says you're doing this in Photoshop, I guess, most of it then, right? What you were doing before? No? Okay.
No. And in fact, you can. And for the most part, up until I started using PixInsight, I did everything in Photoshop, including stacking and all of that stuff. Okay. But now I do everything in PixInsight, which is a software that's designed specifically for astro imaging. But I still use Photoshop because nobody does masks better than Photoshop. So I do a lot of my fine stuff. If I got to take a specific region on an image that maybe isn't the right color or the detail isn't quite where I want it in that specific spot, I can do it in PixInsight. But I'm so used to doing it in Photoshop, and it's so easy in Photoshop. That's usually where I'll do that stuff.
Okay, great. I think that's about all the questions. We had lots of nice comments though about your explanation there, so that's great.
Great.
Okay. So we'll have Paul back again to do a talk on Deep Sky Stacker next time around. Let's hope.
Sure.
All right. Okay, I guess I'm going to take from here. Maybe I'll go quickly to the few photos that we have submitted.
Okay.
And then we're at about 8:39, so yeah, maybe I'll do those really quick. If I can share my screen here.
Yep. I'm just.
Okay. So we only got a few photos, but I'm asking people, I'm pleading with people, send in your photos. we love to get your photos, and we really love sharing them. So be proud of them. Send them in. Let us take a look. We got a couple here from Trudy Allman. Trudy took this beautiful one of the crescent moon the other night.
Oh, that's nice.
Oh, you're there. Okay, gotcha.
Yeah.
a little bit of delay. Okay. Yeah, beautiful shot. I'm not going to say where it was taken from, just the St. Martin's area.
Yeah, out there
Right from
somewhere.
Fairfield. Right from Fairfield. See, I said it, Trudy. And this beautiful one of a halo around. I guess it's the sun.
Oh, that's nice. Yeah,
Yeah.
very nice.
Renat sent this one in. Nice painting. She
Man,
calls it Moon Dance with Gulls and Lobsters Out in the Bay. I'm looking for those lobsters because I'd like to. Well, they must be on the boat.
I caught them. I've already eaten them.
She says it's an original painting by Renat, 16 by 20 acrylic and ink. Full moon illuminating the expansiveness of ice cold waters and the solitary vessel, a lobster boat, gliding on moonbeams through the quiet waters. Okay. This picture is a metaphor for life's journey, its blessings, immensity, and beauty. It speaks of enormous scale and accomplishment, of faith, journey, precariousness, and destination. A beautiful moment of solitude and resolve against the storms of time and darkness. Very well put.
Absolutely.
And that comes from Renat Skelton, and her address is www.renatart.com. If you'd like to check it out, she's got some wonderful paintings there.
I've been on our site a few times, and man, some beautiful paintings.
Yeah, amazing stuff. Oh, where'd this one come from? I kind of grabbed that before I knew that you were going to show it.
Uh-oh.
Uh-oh.
We talked about it.
Hey, doesn't mind. I never mind looking at it again. That's some beautiful shot, Paul. Amazing.
Okay.
Amazing
Thank
capture.
You. Yeah, it was nice. It was murky. So.
Yeah, still to get that out of murky sky. Amazing. I love that's the thing I love about Orion. There's so much in there to look at, right?
Oh my gosh, it's unbelievable.
We've got this one. This comic came in from Deborah Jones. Just cartoon. I like it though. You see all the stars up in there, Nelson? Well, there's lots and lots of them, and they're long way away. Well, I didn't know you knew so much about astronomy. That's perfect. Hey, there's a lunar module.
Oh, whose is that?
That's Mike's.
Oh man.
Mike put it
Is that
together.
Lego?
Huh? That's Lego, yeah. The
Unbelievable.
lunar lander. He got that, I guess, for Christmas, so he slapped it together there the other day. Like Mike puts together, I think it took me a year to put my Saturn V together. Mike put it together like in 12 hours or something, right? And he got to the internet. Oh, what's that?
When he starts on a project.
Oh, I know. He's just right at it till it's done. There's this International Space Station too. That's Lego.
Oh man, nice.
Pretty cool. Yeah, nice stuff.
Absolutely.
Got to get that hanging from the ceiling, Mike. I just wanted to add this one. This is something that kind of brings back for me. This is where I was about a year ago, or a little bit more than a year ago, I guess, in classrooms doing outreach talks. Of course, we changed with COVID, and this is where I am now with the bottom screen. So that's my setup for our program tonight. Basically, the 5 monitors, and each one serves a purpose. But when I'm doing presentations for schools now, I'm able to offer it this way virtually. So I can do a Google Meets call just like we're doing right now with a classroom talk. And I had one just last week at St. Martin's, which is really nice. The kids gave me a bunch of questions ahead of time, so I could go out and find some pretty cool videos to show them to explain the questions that they had. So it went really well, and I am able to do this. I have an employer that's sympathetic to my passion, I guess, a bit. So I'm able to take some time and dedicate it for classroom talks like this. So if there's anybody out there who is interested in, I know we're going into we've been in some orange phases. Some areas are in red now. So I guess visits to classrooms and to groups is pretty well off the plate at the moment for personal visits anyway. So if anybody is interested in some other means though, please just contact me through my page, and I'd be happy to set. This is my setup the other night for St. Martin's, or the other day for St. Martin's, through the classroom talk. So this is possible, and we can still reach kids, and I still want to reach them. There's so many questions out there. The only thing I find unfortunate about this is that there's never enough time in a 45-minute session to cover all the questions that they have. There's so many, and they're all great questions too. And everybody out there seems to have at least one question that they want to get answered, but they just can't. So I try to get them to save up those questions and ask me when we're going through the approach. So.
But you know, this is the new norm. I mean, in media, how they interview people. I mean, this is what you do now. So this is actually nothing that's hard to do for anybody because everybody understands it now because everybody's doing it.
I think
So
so.
I think this is great. I think this is just will be just as effective for you to get into the classroom with this.
Yeah, I'm hoping we're going to be at least, I mean, I know September or longer before we're back in groups again, kind of thing. So, but I mean, yeah, so surely if anybody out there is interested, just let me know if there's kids in your school and they want to talk to their teacher and get a hold of me through my page. I'm more than happy to try to set up something. So I'll leave it at that. And
Yes.
of course, with any other photos, please send them in to SundayNightAstronomyShow@gmail.com. We love getting your photos, and we love displaying them. So that's all I got to say about that.
There.
There. Okay, stop presenting on that part. And I'm going to just go really quickly through, we're at 8:46, so I'm going to try to make this very quick. Just a quick little talk about binoculars, Paul. I'm just going to leave us both on the screen here because I'd like to get your input as well. This time of year, of course, cold skies, cold evenings, but nice, crisp, clear evenings because we're looking out into the darkness of space. We're not looking into the center of the Milky Way now with all that light pollution around it. So we've got a sky that is darker because when we're looking at objects, they're brighter against a darker background, so there's more contrast. So it's much more pleasing for your eyeball. Maybe not for your comfort level, but if you dress warm enough and you're out there and you're not standing on snow, that kind of thing, just moving around a little bit, then you can still enjoy the evening skies. But sometimes you've only got a few minutes or 10 or 15 minutes to take a quick look, like tonight with a beautiful crescent moon out there. So it can go anywhere from a little binocular like this, like a seven times binocular, to some 15 by 70 binoculars, which are really nice light buckets, right? They gather a lot of light. But binoculars are really just two telescopes joined together. I'm sorry, they're just they're like a telescope, two telescopes joined together. So they're just two eyepieces. And the idea about these is that you've got more of a 3D view. There's a lot of things that are a plus with binoculars. First of all, they're very portable. They're lightweight and they're portable. They're reasonably priced. They give you the correct orientation. It's not left to right or upside down. It's the right view, so you can use them in the daytime sky as well. Again, with reasonably priced, used pairs can run anywhere from $40 to $60. I guess I've seen them on Kijiji for that price. Even some new ones have been at that price on places like Amazon or whatever. There's lots of clearances around, lots of telescope stores that sell them as well, including our sponsor, Astronomy Plus. So there's lots of ways to get them. One other thing that it took me a long time to get used to binoculars because they just don't seem to fit my face very well. You know that. We've had that trouble with binos on telescopes themselves. But there is also, you have to stress the fact that there's also a second focus knob here. It's called the diopter. So you don't have just that one wheel. They have the wheel. That's even better than the lever type. But the ones with the wheels are good so that you can focus your left eye. Close your right eye, put your left eye up and use your focus, and then close your left eye and open your right eye and use the other focus.
And leave your left foot out.
There you go. Shake it all about. Do the hokey pokey and turn yourself around. That's what it's all about. All right, so we've got a few.
Go ahead. You, Chris, while you're
please.
doing that?
Yep.
Can you grab those big ones again? Those 15 by 50s?
Yep.
When I was taking a picture of the total lunar eclipse back in 2015, 2015. Can't believe it's that long ago. 6 years ago. Good golly. Anyway, at the same time, I had to set those binoculars set up on a tripod, and I bought this little thing from Farpoint, and it is designed to slip into the binoculars and mount right on a tripod. And this is a good solid metal one. And when I watched that lunar eclipse through those binoculars, it was the most fantastic thing I think I ever saw. Because with those binoculars, of course, you can get the full moon right in there.
Right.
But seeing an eclipse through a pair of binoculars, I can't imagine anything else that looks any better.
Yeah. The moon is, one thing I was going to mention tonight was the moon to look through. And the thing about that mount, like you say, is that, you've got a set of 10 by 50s that are nice and light, and sure, you can sit back in a nice chair, put your arms into your chest like that. That's the best way to do it. Hold your hands out here at the end so that they stay steadier. Otherwise, they're going to shake a little bit on you. And of course, the more they shake, you're magnifying something, so the magnification is going to have to move around a lot too. So just hold them basically out at the end like that. But when you get a big set like this, holding them after 10 or 15 minutes does get, it gets a little difficult unless you're in a real comfortable chair. If you're trying to hold them up this way, it's, so really something with a mount that allows you to mount them to a tripod are best bet for that size. But they give you lots and lots of light. That's 15 by 70, so 15 times magnification. First number is your magnification. Second number is the size of your objective lens down here. So 15 by 70s, a popular size is 10 by 50s. That's usually pretty popular. 7 by 35s is another popular size. So 10 times magnification, 50 times or 50 millimeter lens size at the end. So the larger the lens size, the more light they're going to collect. Of course, with the magnification, 10 by 50 is usually pretty good. You've got lots of objects out there that are great for wide field views too. So like the Pleiades star cluster, and so let's just take a real quick look at a couple of things that I was going to suggest to take a look at. Let me get my list out here. Okay.
While you're getting that out, I was just going to make mention that if you have a larger telescope, like Trudy has a Dobsonian, for example, and the nice thing about binoculars is you can actually find your target with the binoculars. It's like using a finder scope off your big scope, and then once you find them, you basically just take the scope and keep your eyes trimmed right onto the object you're looking at. Drop the binoculars, and you can see exactly where you're looking at in the sky. Then you can grab your Dobsonian or your bigger telescope, and you point it right to that spot.
Exactly. We're going to run out of time to show you where they are in the sky, so I'm just going to bring up the list if I can, and just a few. We can talk about those as I bring them up anyway. Where they are.
Lots of time. Don't worry about anything else. Just continue doing this.
Well, I want to get you onto your Rosanna's talk too. So we're at 8:52. So let me see what we can get through in this part. I'll just share this short list of objects that I might suggest. Oop, going to the wrong screen. Here we go. Try this. Can you see that, Paul?
Yes, I can.
Okay.
Yeah.
I guess number one I would refer to as, like, these are some of my favorite things, but not necessarily all are going to be the best for everybody, or maybe not your favorites. Just a few of our favorites, I guess. The moon is always going to be beautiful in binoculars. A lot of people don't realize that the moon is visible easily with binoculars. You can see a whole lot of detail, especially now when we're into that waxing crescent phase and you start to follow along that terminator line. You start to see detail in craters, some larger areas like the Maria on the moon. So if you don't have a telescope, these are excellent to be able to take a quick look. And even if you do have a telescope, quickly get outside, take a quick look at the moon. If you have 10 or 15 minutes, it's fascinating to look at through binoculars. It's a little bit more painful when you're looking at it in a full moon phase, but that's only a few days either side, so we've still got lots there. The planets, go ahead.
Question that somebody asked, can you find Uranus and Neptune with 10 by 50s?
You can.
I think you can see them, but can you see the colors?
You can.
You see those blues and teals?
Yes, you can. Actually, in the next couple of days, Uranus is going to be right beside Mars. So the moon is going to be your guide. So I believe that's on Monday night, I think, Monday or Tuesday night. I'll post that on my page later. But one of those 2 nights, if you go to Stellarium, of course, you can download that program and take a look there. But I believe it's on, it's Monday or Tuesday night. Uranus will be very close to Mars. Actually, just underneath Mars, you'll see Uranus, and it'll appear as a softer star. Not as a pinpoint like a star does, but it'll appear more like a softer ball, and it'll be a greenish kind of color too, even in binoculars. Even with a telescope, though, you're not going to pick up any detail because it's just too far away. So, but you'll pick up that, and Uranus or Neptune would appear as a very faint bluish type of a fuzzball, basically. So yes, they are both visible, but you might need star charts to find them. That's the thing. You won't be able to see them naked eye. But if you found a star chart, if you went to heavensabove.com, they've got star charts laid out there every night. So you can go in there and find out exactly where Uranus and Neptune are going to be on each night as well. Or, again, a program like Stellarium or one of these apps that you can download as well will show you where they are. So you can find it with 10 by 50s, yes. So planets, Venus, Mercury at present, those are the two. Venus in our morning sky, of course, Mercury in our evening sky. Mercury's climbing higher each night for the next couple of weeks or so as it gets closer to western elongation, which means that's the farthest, or the farthest east in the sky it's going to travel before it starts to sink back down again, head behind the sun. But Venus and Mercury are both planets that will show you phases, just like the moon does. Binoculars are going to be a little bit tougher to pick out that phase, but you can pick it out. And all these targets as well are suited for small telescopes, not just binoculars. But Mercury and Venus, it is pretty interesting to see them, especially when they're in the gibbous phase. You can actually, they'll look like an egg kind of a shape. So they are visible. And Venus, of course, is the brightest object in our morning sky beside the sun. So the Pleiades star cluster, that's a little tiny dipper that seems to appear up in the eastern part of the sky. You'll see it come up before Orion, and it's up in Taurus area. It appears just like a lot of people think it's the Little Dipper, but it's a tiny little dipper kind of a shape. It actually consists of over 1,000 stars, and these stars are all very young, hot blue stars. They're traveling through the Milky Way, basically. So that's really best viewed through binoculars because there's so many of them. To try to get them up through a telescope, it's pretty difficult unless you're using a really wide field eyepiece and a low f ratio, I guess. So Pleiades are a really nice target. Just below the Pleiades is the Hyades, which is the horned kind of a shape of Taurus. Lots of targets in there. Aldebaran, a really nice red supergiant star, but not lots of colorful stars in that area. Of course, the Orion Nebula. We've got the constellation of Orion, the three belt stars that make up his belt. Just below that is this area they call the Sword, and in that area is an area of star birth. Lots of stars are forming in that area right now. So very nice gaseous look to it. You may not see much color. You won't see any color really through it with binoculars, but you will notice that there's a larger cloud there. And it's visible actually without binoculars, although it's visible just naked eye as well, easily. So. Messier 35, 36, 37, 38 are what we call open star clusters. Those are stars that are basically bound loosely.
Below the Pleiades is the Hyades, which is the
sorry, that's me.
Okay. Oh, you can hear me anyway. There you go. Messier 35, 36, 37, 38 are what we call open star clusters. Those are stars, clusters of stars that are bound loosely together by gravity. But they have really nice, pretty stars in them too, all different kinds of colors. Of course, the Andromeda Galaxy is the next closest galaxy to ours at 2.5 million light years away, over 1 trillion suns in that galaxy. It's speeding towards us at 110 kilometers per second. It's going to arrive here about 4.5 billion years from now. Our galaxy and Andromeda will collide together. But through a set of binoculars, it appears as a fuzzball, a smudge basically in your eyepiece, but you'll know that you're looking at light that left there 2.5 million years ago, traveled all the way through space and ended up on your retina while you're looking through it with binoculars. So you're seeing Andromeda as it was 2.5 million years ago. So that's fascinating to understand as well. Sirius, the brightest star in the sky, which is down below Orion to the left. You'll see it as the brightest star just down by the feet of Orion off to the left-hand side or over closer to the eastern part of the sky. Check it out with binoculars too. You'll see that it kind of flashes back and forth. That's just because it's so super bright. It's so low. That light is coming through the atmosphere and it gets dispersed a bit. Betelgeuse, of course, the top left-hand corner of Orion as you're looking at it. That's that red supergiant star that we know that's going to go supernova someday. Probably not in our lifetime, but if we put Betelgeuse in the same place as our sun, it would swallow Mercury, Venus, Earth, Mars, and probably Jupiter would be inside Betelgeuse. So it's huge. It's not Betelgeuse, but Betelgeuse. But if you want to call it Betelgeuse, that's fine too. Betelgeuse was the movie, but we still call it Betelgeuse sometimes. Kemble's Cascade, that's in Camelopardalis, that constellation. It's a string of stars, about 20 or so in a row, all very colorful. They appear like they're in a straight line. Excellent target for binoculars. Mizar and Alcor, the second star in the handle of the Big Dipper. If you notice it with your eyeball, it's usually a test of good vision when you can see a star beside that star. So Mizar is a brighter one, Alcor is a dimmer one beside it. Check it out with binoculars. You'll notice very quickly that there are two distinct stars right there. And actually, each one of those is actually a binary system. So each one of them is a double star. So there's at least 4 stars there, and possibly up to 6 there. And we're not sure if they are either optical doubles that we can just see that they're just kind of close to each other, or they actually do rotate around each other. We haven't found that out yet. But then there's one called the Winter Alberio star. We know Alberio is in Cygnus.
Yay!
Yay! I had to mention it. The head of Cygnus, the swan, is Alberio, and that's a very colorful double star. One is a really golden color, and one is like a sapphire blue color. Both different ages, but they do. That is a double star system. And there's another one called the Winter Alberio. It's, if you punch it in through Stellarium, you'll come up with HR2764. That's the number. It doesn't recognize Winter Alberio in Stellarium, but HR2764 does come up as a double star. So that's another pretty one, and we'll be looking at some of these in a later date, because I'm going to try to do a talk a little bit later on some winter double star targets. Double stars are really nice to look at. They're easy to find, and they give you a nice view through binoculars or small telescope. They're very bright, so you can understand the different colors. And when you see different colors, those are stars at different temperatures, and they're also stars at different ages. So that was about what I wanted to say about them. So I can leave this up for a second. I'll leave it up right now just for a minute, and we can talk about something else. Maybe, Paul, if somebody wants to grab a picture of this while we're doing the video at the moment, we can fuzzball. Sorry, we're not. Talk a little faster, I know. If you wanted to grab a picture of that quickly, you can, and those are some targets to take a look at. Stellarium is a great program to use for desktop. I use it all the time when I'm going out, before I go out observing, and if I'm going to show somebody something else, or if I just want to find out for myself where things are that particular night, or a few nights ahead of time, whatever, I'll bring it up and try to find targets like this. So all nice targets to take a look at with binoculars in this time of year.
Indeed.
And I'll stop presenting. Well, Paul, I'm going to get you to go right ahead with your
Well,
talk.
no, actually, we're after 9, so.
We're after 9? Oh, okay.
Yeah. So
Yeah, try to squeeze.
I'll do the Rosanna talk next week.
Okay.
So she can have a little break if she wants, or
That'd
she
be
can
nice.
listen to it. Maybe we'll do 2 Rosannas next week. Who
There,
knows?
that'd be fine. We're good with that. Okay, any questions on anything that we just talked about there? 10 minutes ago. Okay. There are harnesses for this sold by Birder Supplies. Yes, there are, for sure. Okay, we're all good. All right, I guess we're going to sign off then. We're into 5 after 9. Boy, time goes fast. That evening goes by, just boom, like that. Well, in a couple of weeks' time, too, I just want to mention that Astronomy by the Bay turns 5 years. 5 years old on February the 1st of this year. So I'm thinking about what I'm going to do for that particular date. I'm not quite sure yet. We might end up doing a little focused talk here on our program, but I'll keep you posted. But 5 years, yeah, wow, unreal. A lot has happened in those 5 years. We've been to a lot of places. We've seen a lot of things, met a lot of people. It's been a lot of fun. Had a lot of fun. So I'm really looking forward to talking more about that and looking back at some of our experiences over the last 5 years. So anyway, okay, great. So in closing tonight then, I guess our special thanks once again for all your continued support. We'll see you here again next week, Mike. Thanks again, Rosanna, for your contribution to the show. Sorry we didn't get to it this week, but like Paul says, hopefully we'll give you a break and you'll be back to see us again next week. Thanks as well to all the great folks at Astronomy Plus for sponsoring our program. Remember, too, we do love getting your photos, so send them into SundayNightAstronomyShow@gmail.com, and we'll do our best to get them on the show here for you. We love getting them. And you could also send them into my Facebook page, too, if you're a little shy of sending them on to that address. Just send them into my Facebook page. I love getting them there as well. We're also looking for suggestions for topics for future shows, so if you have any ideas you would like to discuss on a future episode, please let us know at the same address, SundayNightAstronomyShow@gmail.com, and we'll do our best to make it happen there for you. Also, we ask if you joined us through YouTube tonight, please consider giving us a like and subscribing to our channel. We appreciate that. And please let your family and friends know that we are here every Sunday night to entertain and educate you sometimes, but mostly entertain on the night sky. So for now, then, from an absent Mike and Paul and I, please stay safe, everyone out there. Keep your mask on, social distance, wash those hands. Let's get over this thing. I wish we all clear skies out there, and we hope to see you here again next week. And as we like to say here, Paul, keep your scopes pointed up. Have a great week, everyone. Good night. Good night, everyone.